Hello everyone, in this video I'm going to show you how to design a common source amplifier using a MOS transistor. To begin with, uh, let me tell you what you need to do first. First, you need to design a biasing circuit, and the biasing circuit has to satisfy the cutoff condition. The cutoff condition dictates that the gate to source voltage has to be greater than the threshold voltage. And you also need to satisfy another condition, so-called the saturation condition. Without the transistor being in the saturation region, you will not get any gain. In the saturation region, you need to make sure the drain to source voltage is greater than the gate to source voltage minus the threshold voltage. So these are the two important conditions we need to satisfy. So now let's start with this transistor. This is the very typical MOS transistor. Let's take a look in the model first. So if you take a look in the model, you will notice the threshold voltage is around 1.9 volts. It's a low frequency device. You can see it from the capacitance. And what I can do now is we need to make sure the gate to source voltage is greater than the threshold voltage, which according to the model is 1.9 volts. So to make our life simple, my suggestion is you make sure the source is 0. This is the easiest way to begin with. So the next thing that we need to do is to make sure whatever voltage you have at the gate, sorry about that, whatever voltage you have at the gate is exactly equals to VGS, because you have already set VS, the source voltage, to be 0. Then whatever voltage you have in the gate is the gate to source voltage. Now we have to make sure the gate to source voltage is greater than 1.9. I mean the threshold voltage. So what we can do is, but we don't have to make it too large. We just make it just close enough. So I will make it say 2 volts. We will force this value to be 2. So what we can do is we can use a DC voltage source, say 10 volts. We will make it 10 volts. And we will use the voltage divider to come up with exactly 2 volts here. And as you know, there will be no DC current going to the gate. Then we can choose whatever resistance combination we need to end up with 2 volts. So I can do 2 mega here and 8 mega here. So in this case, if I connect a voltage divider like this here, and I will connect the ground here. So the gate voltage here will be 2 volts. Definitely it will be 2 volts. Then we have already satisfied the cutoff conditions. We'll move this transistor, this ground a little bit low to make or we can just connect it together to make the circuit clearer. Now the next thing is we need to design a current. You need to find out the condition of saturation. So here is my suggestion. We can, to start with, we need to place a resistor here. I would place the drain resistance. Yeah, to start with, we will make it about 100 ohm. Yeah, we just randomly put the value here. It has to be not too much, not too small. So we will label this as RD. So now we are about to check the saturation. And what we can do now is we pick the operating point analysis. And we will simulate the circuit for the operating point. And once you do that, then there are many values here. My suggestion here is you label the LED, so you'll never get confused. So I will label here as the source. I will label here as the drain. And I will also label here as the gate. So now I'm going to simulate the DC operating point again. So I can see that the gate voltage is exactly 2 volts and the drain voltage is 7.15, so it's quite large. And also I got a very large DC current here, 28 milliamp. You can, at this stage, you can change the value here in a way that you satisfy this condition. So according to the simulation result, the drain voltage here is greater than the gate voltage here. The gate voltage is also the gate to source voltage, and when the gate to source voltage minus the threshold, which is 1.9, then the gate voltage, the drain voltage is usually much larger than the gate to source minus the threshold voltage. So in this case, definitely we reach the saturation, but the current could be a little bit too large. But it doesn't matter, right? As a matter of test, we can just just get a rough check. Now, I'm going to move the text away. Now what we need now is to build a common source amplifier. What you can do is you add a capacitor here to block off the DC. So this is so-called the coupling capacitor. And I will make it 1 micro. And we'll make it 1 micro. And then we'll connect the voltage here. And now you need to check the voltage gain. So my suggestion is to use AC analysis.